to the healthcare.ai live broadcast. This week we've got a great show. I'm Mike Mastinduno, joined by my co-host Mike Levy. This is the first time we've worked together, Mike. Pretty exciting.
Exciting to be here.
Yeah, awesome. So we've got a great show this week. Mike's going to do a really in-depth analysis on data exploration in R, so it'll be a pretty heavy hands-on week, and I think we've had a lot of user feedback that people like that, so it should be really exciting. And I got a sneak peek of the code, and I have to say I learned some things already, so I'm excited to see it as well. Before we begin, though, please remember to log into the YouTube channel. We will interact with you through the chat, so if you have any questions, let us know. And while Mike's doing the code, I'll be reading the questions and trying to work them into the conversation. You can subscribe to the YouTube channel to get notifications when we go live, although it's this time every Thursday, so the reminder can still be helpful. And if you'd like to join our community to interact throughout the week, it's on the Healthcare.ai website. You can join the Slack channel, and we've got, it's about 200 people on that channel now, and there's a fairly healthy discussion every week, so we'd love to have your thoughts contribute to that as well. And then as one final plug, if you want to come out to Salt Lake and meet us in person, we're doing a 2-day workshop at the beginning of the Healthcare Analytics Summit that'll focus on machine learning and data analytics using R, and that should be really exciting as well. That's in September, so we hope to see you in any or all of those forums. And without further ado, let's get into the show. So we'll start with In the News this week, and we have a couple of papers on healthcare machine learning that we both thought were pretty interesting. And so we'll start with, there's a paper on de-identification of clinical data using generative adversarial neural nets. And so basically the idea is that it's hard to open source a data set in healthcare because there's a lot of privacy concerns around them. And we found that a lot, trying to share data sets with the community, or we've talked about doing a Kaggle competition, and that's hard just because of all the privacy concerns. But so this group decided, well, maybe they could take a data set and use an adversarial neural net to simulate data based on the real data. And so they did that. All the different patient data is used to kind of synthetically make new patients. And then to evaluate it, they used a different neural net that would try to classify whether the data was real or fake. So basically have the generator try to fool the evaluator. And so the two nets kind of work together to build a really nice data set that has some standards as far as how difficult it is to trace a single row of generated data back to a real patient. So they did that, and then the method, they say, is able to kind of, they use it to, they could give it out so people could do things like use healthcare.ai to explore that data and find trends. And then they also found in their code, part of the research was, well, if you take their generated data and train machine learning models on it, can you generalize those models back to the real data? And in the data sets they tested, they found that it was possible to do that. So very cool. It's definitely a fairly complex solution.
And a really unconventional use of neural networks.
Yeah.
We don't think of them as being used to create data sets, but really neat application.
Yeah. So, maybe you'll see de-identified data sets coming from us, or maybe you'll see them getting run through a series of complicated neural networks first. But either way, very interesting. The other study we wanted to talk about was a recent publication in Archive from the Stanford ML group. Andrew Ng is on this paper, and you may remember him as the author of the great Coursera course on machine learning. Anyways, his group, they did a collaboration with Irhythm Technologies, which is a wearable ECG device that monitors your heart's behavior over time. And they found that they were able to use the data and a convolutional neural net that they trained on the data to come out with better than a cardiologist could do to interpret the data. So let's kind of step through that a little bit. They found, let's see, I'm going to switch off to my notes, but they found they found 64,000 records from about 30,000 patients and had those annotated by cardiologists, and then built a 34-layer convolutional neural net that would eventually generate a prediction every 12 seconds. And so you can see an ECG as the signal that kind of it's continually collected, and so getting a prediction every second. If the heart's behavior changes, you would see that with that time resolution. And so they tried to classify using that big neural net, and they've got the architecture here, into 12 different categories. And for the most part, they agreed really, really well. I thought they evaluated the model in an interesting way, where they reserve a test set of about 300 cases and had a committee of cardiologists label them so it could be done as accurately as possible. And then they had that same test set evaluated by individual cardiologists as well as the neural net. And the neural net performed maybe 4 to 8 percentage points better in precision and recall, kind of across the board of categories and stimuli. So that's a really interesting study, and I think it kind of starts to bridge the gap from academic studies towards more widespread studies, which is the kind of stuff you have to do to put models into production. It's a much bigger data set than that's ever been tested, and it's done on more data. So you start to get some of those complications that come with putting a model in production and actually using it rather than just publishing a paper. So if you're interested in either of those two papers, we'll send out links to them after the broadcast, and you can check them out. All right. So now we'll move on to the mailbag. We did have some great questions from users this week. And so, the first one, Mike, are you ready to answer some questions?
Let's do it.
All right. So the first one here is, throw you a real tricky one. My console in R Studio seems to have locked up. Is there a way to stop R?
There is. There's a stop button that appears when R is executing code.
Ah, okay. So you can just press, and does it look like a stop, or what does it look like?
Let me do this real quick.
Okay.
I will set this up.
I'll try and get that for you. Got a little adapter here. There we go. We can show you the stop button in action.
So, this is a script that I will use to do the exploratory data analysis that we were talking about. But in the meantime, let's give R something hard to do. So let's say, let's do this. Let's do for I in 1 to some large number, something like 1,000,000, print I. So that'll go. It'll take a little while. And while it's doing it, this stop sign appears. If I press that, that stops. Or the keyboard shortcut for that, I believe, is the escape button. So most of the time that'll work. Where it gets tricky is a lot of R functions under the hood are implemented in a lower level language, in Fortran or C or C++, to provide speed gains. And if R has called one of those languages and is executing code in that language, then that stop button won't work. So to demonstrate that, let's take the median of all these numbers. So median is a fairly computationally intensive calculation. So if we try to take the median of all the numbers from 1 to 1,000,000, let's see how long that takes. Well, not very long. Maybe 1 to 10 million. All right, maybe 1 to 100 million.
There we go.
Now if I hit, too fast. R is fast. And I got this nice new computer from Health Catalyst. It's very fast as well. All right, 1 to 1,000,000,000, I think that is. Now it goes, if I hit stop, R doesn't respond. It's down running Fortran code to find the median of that vector. And so if I want to interrupt this, R might ask if we want to interrupt the process that it's running. It does. So if we say yes to this, it will shut down R, it will shut down the underlying process, and we'll have to reload R, but we'll lose all of our working data. So we can do that if we want to interrupt the whole process, or we can wait for it to come back from Fortran, and then we preserve the data in our active working session.
All right, that's a great answer to a seemingly simple question. So while your computer comes back to life here, Mike, do you have any books that you recommend for R, or what's the best way to learn R?
Yeah, this is a question we get all the time. There are so many good resources on the web, in books. Obviously, there are a million online courses. A lot of them are free. I happen to like Data Camp's online courses a lot for R. For books, my suggestion would be to look for substantive areas of interest that apply R and get into it that way. So for me, I learned R really starting in statistics classes during my PhD. If you're interested in Bayesian statistics, I can't recommend the book Statistical Rethinking by Richard McElreath strongly enough. And that teaches Bayesian statistics through R. So you're almost distracted from R while you're learning the statistics, and then you kind of learn R without even knowing it.
Got it. So you would suggest, maybe finding a subject area you're excited about and then kind of using R to explore that subject area.
Exactly. There's a new book on text mining in R called, I think, Tidy Text. So if you're interested in NLP or in text analytics, that might be a place to go.
Cool. Is that by Julia Silge, by chance? Oh, okay. So another Salt Lake data scientist. We featured her work a couple weeks ago in a broadcast on NLP. And then finally, we have another question on basically, how do you Google something? So in R, there's the tilde function, which means as a function of in R. But that's, sometimes things that are that inherent to the language are hard to Google. So how do you figure out kind of the syntax or the things that the creators of the language just assume you understand?
Right. So in R, as in life, there's an art to Googling things, right? And it's a skill that is tricky, but it's important. So if we wanted to know what the tilde means, I might Google something like R, what does tilde mean? And the first response is a Stack Overflow question that looks like it addresses exactly what we're interested in. And then you can see, so the fourth link that comes up for me is the R help page for the tilde operator, which is, in this case, pretty readily comprehensible, right? The tilde is used to separate the left and right-hand sides of a model formula. So R help files are great. They often come up in Google help searches. And then Stack Overflow posts, of course, are always useful.
Great, thanks, Mike. Those are some great answers. So we've done the In the News, had some really interesting papers, and we've done the Mailbag, got some good questions. Again, please keep your questions coming into the chat, and there's only a couple of questions in there, so chances are, if you're curious about something, you will get an answer. So I guess let's move on to the main event here. We've got a demo on kind of exploring some data. Mike's an expert in exploring data and in using R, so he's agreed to walk us through a data set. So Mike, take it away.
Cool. So the data that we're going to explore is from the UCI, the University of California Irvine Machine Learning Repository. There are lots of great data sets there, almost 100 related to healthcare and a bunch related to other areas. So if you're interested in exploring data, getting your hands dirty in R, it's a great place to start. This one, our intern Ethan pointed me to, it's a data set on readmission of diabetes patients. So it came in a comma-separated value form. So I've saved that on my machine in this location, and I will read it into R using the read CSV function. Maybe, but I need to set my working directory first. So this will be now that points in the right direction. So let's take a look at that data set. My first tool to look at a data frame is the structure function, str. I'll try to make this a little bit bigger here. And the structure function tells us the size of our data set. So here we see we have just over 100,000 rows and 50 columns. It tells us what kind of variable each of those columns is, and then gives us the first few entries in each. So this gives us a nice sort of high-level view of our data set. And one thing that I notice immediately looking at this is that several of the columns have question marks in them. So R has looked at this race column, it's seen entries with a question mark, and interpreted that as a level, just like African American. That's probably not right? I think we can probably safely assume that the creator of the data set used a question mark to reflect a missing value.
Mm-hmm.
So let's tell R that those question marks mean missingness. The readCSV function has an argument to do just that. So if we come up into here, I'm going to hit tab to scroll through the arguments available in readCSV, and I'll start typing NA. We see this argument for NA strings, which the help file says is a character vector of strings which are to be interpreted as NA, or missing values. So I will say NA strings equals question mark, and if I run that, and then look at the structure of D again, make this just a little bit wider. Now we see, instead of having 6 levels, one of which is question mark, now there are 5 levels. And those question marks have been interpreted as missing, which shows up as NA in the data set like this.
Do you know if that would work if you had multiple NA?
Yeah, so in this help file, so let's do this. As I do tab completion here, it says that NA strings can be a character vector of strings. So you can combine multiple strings that are meant to reflect missing values. So maybe question mark, a blank cell, the text NA. You could say that all of those should be interpreted as missing. Right. So now that R knows where the missing values are, we should try to know where the missing values are, right?
Yeah, that sounds like a great idea.
Often data sets, especially in healthcare, will have a lot of missing values, and if you're not careful, it's easy to be led astray by those missing values, right? If values are missing for some good reason, if you don't have measurements at certain times in the care delivery process, and you try to model the data without accounting for that, you can end up with biased results. So there are a few ways we could do this. Let's do this.
Maybe you could start by getting the percentage of each column null values or something.
Yeah, so...
Or even just counting them.
Let's do this. So if you're familiar with the apply family of functions in R, when we use sapply on a data frame, it's kind of like doing a for loop over the columns in the data frame. So sapply of D function of X. So everything I write in here now, X is going to refer to one column in the data frame. So if I ask for sum of is.nax, that will tell us, that will count the number of NA values in each column. So if I run that, I see that a lot of the columns have no missing values, but some, this third diagnosis has 1,400, race has 2,300, weight has almost 100,000. So 100,000, that seems like a lot. I don't remember how many rows there were in the data frame. So what I can do is I can divide that whole vector of the number of missing values by the number of entries we have in the data frame, the number of rows in the data frame. And that will tell us the proportion of missing values. So we see that payer code is missing in almost 40% of the rows. But still, like, there are a lot of zeros. It's hard to tell where most of the missingness is. So we can sort this whole thing to look at that. So if I wrap that whole operation in sort, then it will give us all the zeros up front, and then we can easily see that weight is missing in the vast majority of cases, in 97% of the rows in this data frame. So given that, we probably want to do something about those missing values.
Yeah, I'd say we should clean them up.
What should we do?
Well, let's see. We could fill them in, or we could remove them completely.
Yeah, totally. So filling them in, we call that imputation, and there are various levels of sophistication of ways to do that. Sometimes you might have substantive knowledge, so you know what to fill in. So maybe a missing value actually reflects a 0, and you can just fill that in. We often use mean imputation as kind of a quick and dirty way to get those missing values out of the way. Or if you want to be sophisticated about it, you can use multiple imputation, these sort of advanced statistical techniques. For today, let's get rid of that weight column, right? We don't think weight is going to be a super important variable, and we don't have it on hardly anyone in this data set. So let's just get rid of it. And in R, we can do that like this. So I'm going to subset the data frame D. When I use this comma in the square brackets, what's before the comma refers to the rows. what's after the comma refers to the columns. So here I want to tell it not the column that's named weight. And I'll do that like this. Which names of D equals, do this. Let's run that. Row.
Column in, right?
Value of everyone who at all, and if they were readmitted, was it within 30 days of being discharged or after 30 days of being discharged? So let me just articulate that question in writing. Is there a difference in readmission for patients whose medical specialty is missing? So the first thing I would think to do is to make a cross table or frequency table of the counts of readmissions for people whose medical specialty is present versus absent. So this is a medical specialty gets us whether that medical specialty is missing or not. We can use the table function in R to look at that. So if we do table on just is a medical specialty, we see that, again, we have about half missing and half present. If we provide that and readmitted, then we get this nice cross table, and we can see the counts of people that were readmitted within 30 days, after 30 days, or not at all, and whether their medical specialty is missing or not. Does it look like there's a difference between people whose medical specialty is known and those who aren't in their readmission status?
I can't see your screen. You're going to have to answer that one.
It's hard to tell from the crosstab, right? And I don't know, just not that particular. I don't know.
Let's say I could look at the crosstab. It's still hard to tell.
It's hard to tell, right? So these are like numbers. They're pretty big numbers. They look kind of similar, but maybe they're a little bit different. Visualization is a key part of exploratory data analysis, right? It's hard to look at raw numbers and see patterns. We are visual creatures. It's easier to see patterns in visualizations. One awesome thing about R is that plotting is often as simple as this. So I can just do plot, I think this will work, plot of that table, and R will pick a sensible kind of plot to plot that table. So this is called a mosaic plot, right? It looks like tiles. And the size of those tiles is proportional to the number of entries we have in each cell. And here it looks like, for people whose medical specialty is missing, so that's the folks where this is true, it looks like fewer of them are not readmitted and more are readmitted. It's not a huge difference, but that becomes visual there and perceptible in a way that it's maybe not with the raw numbers.
For sure.
Now, if we wanted to test that statistically, we could do that with a chi-square test, right?
Yep.
A chi-square test is meant to test evenness of distribution across categories. And again, so I'm going to use tab completion to find that function in R, and it's chi-square.test. And then again, it's the same syntax. So I take that table, that crosstab, throw that into chi-square test, and there's some output. And it tells us that the p-value for this chi-square test is incredibly small, right? It's very unlikely that we would see this level of imbalance in classes if they were actually evenly distributed. So it looks like we do have a difference in readmission for folks whose medical specialty is known versus unknown.
That's very interesting. Okay. So I guess that kind of covers, I think you did a good job answering that question.
Thanks.
You got a lot of depth in there. Are you ready for a different question?
Let's move on.
Okay. So now I guess I'm interested in, just some data exploration,
Sure.
Let's just try and learn something about the data. So maybe, do older patients have longer or shorter stays than younger patients? Kind of a similar question.
Similar kind of question, except we're dealing with continuous variables now rather than categorical variables.
Okay, so
right?
this table approach might not work as well.
Yeah, right, because we'd have to bin ages into some category, and we'd have to bin length of stays into some category, so we'd lose some detail in the data by doing that.
Right.
Let's take another look at our data frame, get oriented to what the names of the variables are. So we have age is called age, and it looks like it has been chunked into decades.
Okay.
And then we have time in hospital, which I believe is the number of days that the patient stayed in the hospital. So let's maybe start by looking at the distribution of each of those variables just individually.
Sounds good.
I will do that with plot density of the variable. So let's do plot density of time in hospital, and we get a density curve of the length of stay. So it looks like the most common length of stay is 3 days, and only a small fraction of folks are staying upward in the two-week range.
Mm-hmm.
And then since the ages are binned into categories, I would look at those with a table like we did previously. And of course we could plot that like we did before. All right, that's cool. That gives us some intuition about the frequency. We mostly have older folks in this data set, but now we want to look at the relationship of those two variables.
Right.
So we have one continuous variable, one categorical variable. That sounds to me like maybe a box plot case.
That sounds pretty good.
All right.
Now, you've been talking about base R so far, but is ggplot significantly better for this sort of thing?
Oh, that's a question that people fight over. ggplot and base R are both excellent graphics engines.
Mm-hmm.
They have different strengths and different weaknesses.
Okay.
I think ggplot is great for this kind of thing, for exploring data, rapidly iterating,
Mm-hmm.
and then making graphics really pretty.
Mm-hmm.
Right? Base R is maybe a little bit more flexible, but ggplot stuff just looks good right off the bat.
Got it.
So let's use ggplot for this. So I will load ggplot into my session with library ggplot2, and then let's do this. ggplot, I give it the name of the data frame, and then I want on the x-axis the age of the patient. On the y-axis, the time in hospital. And then let's try a box plot. Let's see what that looks like.
So that's just the default box plot.
That's the default box plot in ggplot. And like I say, that looks pretty good right off the bat. Gives you a pretty good sense of the distribution of length of stay across these time frames.
Yeah.
If we wanted to look at that in a little bit more detail, we could look at the entire distribution
Mm-hmm.
of the length of stay in each age class. So I might do that. So again, actually, to show how easy it is to iterate with this stuff, I will copy this code and just modify it a little bit. So instead of mapping X to age and Y to time in hospital, I'm going to put time in hospital on the X-axis, and I will put fill. So I'm going to use different colors for age, and then we'll draw density curves, and we will use facet wrap to separate out the different ages so they each get their own little plotting area. And then we get the full distribution.
Very nice.
Yeah, right? It's very pretty.
Yeah.
We get the full distribution of length of stay for each age category. And then to iterate just one step further, we can, so let's say we have another variable that we're interested in. Maybe we want to look at whether length of stay differs across sexes as well as across ages. No problem. Let's change fill from age to, I think it's gender in this data set. So I change one thing in that plot, and then we get a breakdown across genders. Couple issues there. It looks like the males are obscuring the females in ggplotting as in life. And we also got this unknown gender category that it looks like maybe there's just one observation of or something, so we might want to filter that out. So let's go ahead and take care of those things. Let's clean that up a little bit.
Mm-hmm.
So we'll do D, and I will filter out where the gender is not equal to unknown / invalid. And I'll add a little bit of transparency to those curves. So let's give it an alpha channel value of 0.5, so it'll be 0.5 opaque, 0.5 transparent. Let's see how that looks. Cool, that's getting better.
Yeah, looks pretty good.
So we see those spikes in each of the curves. That's the density smoother is maybe a little bit narrow for this data set. We can adjust that with the adjust parameter, lengthen that out a little bit, smooth the curves. It's cool. And so looking at that, now we can see that it looks like here, women tend to have slightly longer stays than males in like the 20 to 40 age range, but not elsewhere in the data set. So maybe like in childbearing years, maybe women are seeing additional complications or something. So in like 15, 20 minutes, we've explored this data set, took care of some missing values, and we're already starting to like point at some potential insights, things to explore further in the data set.
Yeah, and the nice thing is too, the way you set this up, if we wanted to look at a different variable, all you have to do is change the name.
Plug and play. Yeah, copy that variable name, paste it into the code.
I gotta say, when you use R, it looks a lot better than when I use R.
That's 5 years of a PhD banging my head against it.
There we go. Is there anything else you wanted to explore, or do you want to leave it there for this week?
I know we're running pretty long. Let me show one more thing. So if we wanted to keep this plot, we want it not just in R, but we want to maybe send it off to the CEO or something. Okay, maybe that's ambitious.
You want to put it on your mom's fridge.
I want to put it on my mom's fridge. That is more accurate. I can use the ggsave function, and then I give it the name of a file. So I'll call this myplot.png. And if I just execute that line like that, it saves conveniently with the same dimensions as were up in my RStudio window. And so now if I go to, whoops, not there. If I go to the folder that I was in my system, now I have this image waiting for me, and I can email that off to my mom, and she'll be impressed with what I've done.
She sure will be. So that's a great intro to data exploration using mostly base R. Now, a lot of people talk about, just like ggplot, a lot of people like to use the tidyverse to do data prep or exploration. So maybe on a future show we can do kind of a similar workflow in the tidyverse.
That'd be a lot of fun.
Great. Well, thanks for joining us this week. That wraps up our show. I hope you enjoyed it. And do you know what next week's show is?
I don't remember off the top of my head.
I can't remember what it is either, but I'm sure it's going to be fantastic.
It'll be fascinating.
So you can look for your updates or the descriptions on healthcare.ai to figure that out. So thanks a lot for watching, and we'll see you next time.
Thank you.